Indefatigable. Okay, so when you are dividing polynomials, remember you set up your divisor, and your divisor dictates how many rows there are going to be, and then the columns just follow as needed. So 2x and 5 would make 2 rows. So 4x to the 4th here, that would give me 2x squared. 2x squared times 5 is... Thanks. 10x to the 3rd. And now I want to create a 4x to the 3rd. Oh, do I got this backwards? You guys lead me astray. Hey, I once saw a t-shirt, hopefully you guys will get this, and it had a picture of a devil, and it said, "I never said it would be worth it, I only said it would be easy." Some of you don't get that. Have you ever heard, "I never said it would be easy, I only said it would be worth it"? But this one was the other way around. Anyway. So, negative 6x to the 3rd, which would give me a negative 3x squared minus 15x squared. I have a negative 15, and I want a 1. So how do you go from negative 15 to 1? Add 16x squared, which on top is going to give me 8x. And then 8x times 5 is 40x. I have a 40x, but I want a negative 10. So subtract 50x. And that would give me negative 25x, or just 25, no x. So minus 100, is that what I wanted? No, I have a remainder. So, oh, you guys can't, I don't trust you anymore. Okay, is that what I wanted? No remainder. So my answer is 2x to the 3rd minus 3x squared plus 8x minus 25. And that one went in evenly. Okay? And this worksheet is basically the same thing, but there are some tricks thrown in that are a little bit different. So, for example, look at number 3. What's wrong with number 3? There's no x squared. So when I get to that point, I'll show you, x and 4, I'm missing an x squared. Is it an x squared row or column? No, it's an x squared diagonal. So when I get to the x squared diagonal, the sum needs to be 0. So it might help to insert 0x squared, just so you remember. 2x to the 3rd. So this would be 2x squared, 8x squared. And then my 8x squared needs to become 0x squared. So this would be minus 8x squared. So on top I would have 8x. 8x times 4 is 32. Oh, you're right, I'm sorry. Oh yeah, you can do that anytime you want. Okay, so 32x, what am I looking? Negative 32x. Thank you. So I need to create a negative 4. How do you go from negative 32 to negative 4? Positive 28. So this would be 28. 4 times 28 is going to be 112. Oh, this one does not have a remainder. How nice. What if it did have a remainder? Just remind me. You would put the remainder and then divide it by x plus 4. Okay. So if you're missing a 0 in the numerator, it's really easy. Okay, what if you're missing a 0 in the denominator? That's different. For example, look at number 10. So how many rows is this going to have? 3. And you might ask, well, you won't ask yet, but eventually you're going to ask why we even bother. So x squared, what's my second row? 0x and negative 3. Okay. So I put in 3x to the fourth. Let's see if I can do this without making a mistake. 3x squared times 0, 0x to the third, and then minus 9x squared. Okay, next column. I need, 0x to the third, right? So this, let me draw the diagonals. These two boxes need to sum to be what? 0. So how much more do I need? 0. Well, x squared times, or how many times does x squared go into 0x to the third? 0x times. Well, what is 0x times the remaining two terms on the left side? 0x squared and 0x. Okay, so now I look at this diagonal, and that diagonal needs to sum to be negative 25. Oh, wow. A moth is, I've never seen a moth in here before. It flew into the light. I haven't seen a moth come in this room since Aubrey walked in. I almost said that with a straight face. No, I was trying not to laugh. Okay, so how do we get from negative 9 to negative 25? Minus 16x squared. So this would be a negative 16. Negative 16 times 0 is 0x. Negative 16 times negative 3. Is that 48? Man, none of these have remainders. Okay, so why did I bother writing down all those zeros? Well, technically, I could have just done 2 rows. X squared and negative 3. But that's going to create one big problem. The diagonals won't line up anymore. So, well, if we delete this row, now the diagonals, so if we, well, so 3, let me write it out. You're still going to have a 0 column, either way you do it. Okay. And then negative 9x squared, 0x, and 48. So, this term matches that term, which is a pain. I guess you could. But here's an easier way to do it, okay? If you have a 0 here, the fact that it's a placeholder is important. So when you write that, just write a bunch of zeros. Or just cross something. You don't actually need to calculate it, because once there's a 0 in one row, the whole row is going to be 0. And once there's a 0 in one column, the whole thing's going to be there. But if you don't put the placeholder in, then adding up the terms is confusing, especially when it gets bigger. Because you might add up terms, and there might be one missing that you don't even realize is missing because it's not in order. So I highly recommend putting in the 0 row, even if you just write it and leave it blank. It skipped a term. If you look at this, we have an x squared, x, and a constant. We're missing that. That's why there's a 0 row, because that particular problem did not have an x in the middle. Okay. I want to do number 8 because something funny happens in number 8 if we fixed it right. We tried to fix it this morning, and hopefully we did. We'll see. So how many rows is this going to have? 3. Number 8. 3x squared, and then I'm going to have 0x and negative 2. So I'm just going to go ahead and write zeros here, just so I don't have to think about it. And maybe more zeros. I don't know yet. So 3x to the 4th. This would be x squared. So minus 2x squared. And then this is my x to the 3rd box. What does my x to the 3rd diagonal need to add to? 0, because it's not there. So if this is a 0, then that's going to be a 0. Okay. So now I look at my x squared diagonal. What does my x squared diagonal need to add to? It needs to add to 4, and I have a negative 2. So I'm going to add 6. 6x squared. And how many times does 3x squared go into 6x? 2 times. And 2 times negative 2 is negative 4. Wait a minute. Something's not right. Oh, okay, we're all right. So, now what? Am I done? Did it work? Right. I still have this diagonal to deal with, right? So, this is my x diagonal. And my x diagonal has a sum of what at the moment? 0, and it needs to add to be negative 13. So I need a negative 13x here. Well, I don't have any room left, right? That's my remainder. Now, let's suppose, well, let's finish this and then I'll show you a hypothetical in a second. So it's plus negative 13x over 3x squared minus 2. Okay, anything that happens after this line is a remainder. Okay, now put your pencils down and just watch this for a second. Let's say that when I multiplied this out, I got a negative 6 instead of a 4. Okay, and we know this is 0 because the whole row is 0. So is my negative 6 good enough? No. What do I need in this diagonal? I need a negative 4 and I have a negative 6, so it would be plus 2. So my remainder turns into a binomial. Negative 13x plus 2 over 3x squared minus 2. So your remainder can be any polynomial that is 1 degree less than your divisor. So if you divide by an x to the 3rd, you might have a remainder that looks like this. Over x to the 3rd minus 4x plus 1, or something like that. So this degree can be as big as one number less than that. And it gets much more complicated because let's say that this number is not actually a multiple of that number. Then your answer is going to be some sort of fraction, and it gets really messy. But we're not going to give you problems that are that hard because it doesn't really have any use. Okay? The biggest thing about polynomial division is if it works, it's useful. If it doesn't work, if there's a remainder, then we don't care too much about it. So yeah, it's supposed to be x squared. So number 8 on the answer, get rid of the 3 on the answer. Okay, good luck.